of atmospheric behavior. When the mathematical models are combined with information returned from already operating satellites, it may be possible to make forecasts 2 to 3 weeks in advance. Communications. Some of the greatest strides in putting space to work have taken place in this field. In 1960, Americans made 100 billion telephone calls. In 1969, nearly 200 billion were made. New uses are continually being found for telecommunications. Banks, stock exchanges, hotel reservations, cable TV, hospitals, computer centers, and other new customers are appearing at an increasing rate. We are in the midst of a global communications explosion. Helping meet this demand are communications satellites.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as ECHO.
August 12, 1960. President Eisenhower took part in the historic first transmission via ECHO satellite. By bouncing radio waves off its shiny surface, it made possible long-distance telephone conversations and the transmission of photographs and music. Other communication satellites followed: Telstar, Relay, Syncom, each a research step leading to commercial spacecraft capable of handling satellite communications. In 1964, television viewers around the world were able to watch the Olympics from Tokyo. A visit to Mexico City by the Pope was also viewed globally. Over 500 million people, 1/6 of the world's population, saw man's first steps on the moon. Color coverage of space recovery operations from mid-ocean is now routine. At the Manned Spacecraft Center in Houston, doctors discussed space medicine and early cancer detection. The proceedings were telecast live via communication satellite and provided two-way voice circuits between the United States and 3 European countries. The closed-circuit telecast enabled 30,000 European doctors to hear the 3-hour transatlantic conference. One of the best ways to check out new concepts and techniques in communications, navigation, and meteorology is with research and development spacecraft. The applications technology satellites are just that, serving as platforms for testing out new concepts in all these disciplines. The ATS program consists of 7 flight missions. 5 of these have already been flown. Probably the most unique characteristic of the ATS is their ability to receive and transmit from a number of widely separated ground stations simultaneously. They can handle telephone calls, transmit television, teletype, radio voice, and weather data all at the same time. Keeping in contact with the SS Santa Lucia as it steamed between New Jersey and Chile, ATS demonstrated the feasibility of using satellites for high-quality, reliable ship-to-shore communications over long distances. A similar test was made with a U.S. Coast Guard ship. ATS has been used to relay information from remote instruments and buoys, a step toward future data relay satellite systems. A successful experiment to transmit television by satellite from the east to the west coast took place with the help of the Corporation for Public Broadcasting.
These current tests are enabling NASA and the broadcasting community to iron out technical problems that are involved in this form of transmission and to determine the costs of such future operations. If these tests are successful, and we have every reason to believe that they will be, the American people will reap a major domestic dividend from the national space effort.
The program was relayed from a ground station in Rosman, North Carolina, through the ATS to KCET-TV, the educational station in Los Angeles. As soon as the receiving equipment is operating, Alaskans will have educational radio and television programs beamed to their state. Through an agreement signed with India, an applications technology satellite similar to the one shown in this artist's concept will begin telecasting instructional television into 5,000 Indian villages by 1974. India will provide the TV programs. The results of this cooperative experiment are expected to provide an understanding of the effectiveness of satellite systems in meeting the needs of other developing countries. A satellite-to-satellite laser communications experiment is also planned on future ATS spacecraft. Beams emitted by a laser can carry immense quantities of information. Communication satellites hold great promise for navigation and traffic control. Today, airplanes flying over wide open areas of the oceans are out of radio range for periods of an hour or more. The problem is compounded by the fact that most airlines going to Europe from New York, for instance, want to depart at 6 p.m. to serve dinner and show movies. They also want to go to the same altitude to take advantage of favorable tailwinds. The problem, then, of keeping international air traffic sufficiently spaced becomes more and more serious. NASA has been experimenting with a system to determine the position of planes and ships. The system makes it possible for a ground-based station to automatically locate aircraft and ships equipped with receiving and transmitting equipment.
Gunner Mobile number 2, Pan Am Silver 271. Position here from INS readout is 31 degrees, 32 minutes north, 70 degrees, 1 minute west. Flight level 330. This is 271, over.
In recent tests, position accuracies of less than 1 mile error have been achieved. Results of this work could lead to advanced techniques for satellite position fixing and traffic control, and aid in the solution of some of the world's transportation problems. Space geodesy has taught us the true shape of our planet, where it flattens, how much it bulges. With these results, we are better able to map the Earth and to navigate. The orbital path of a satellite is not a perfect circle. The satellite weaves sideways and up and down as it travels its course around the Earth. These deviations are measured only in feet, but they can be detected by Earth-based tracking stations and reveal new facts about the Earth's structure. Satellites have been tracked by laser. After predicting where spacecraft will be at any given time, telescope-mounted lasers swing into position, and aided by computers, their pulses of light lock on and track the orbiting craft. 3 of NASA's Explorer satellites carried special reflectors that mirrored the laser light flashes. The positions of the satellites were precisely determined, and the distance calculated simply by measuring the time it takes the beam to go to the satellite and return. Precision in satellite tracking leads to precision in terrestrial mapmaking. The Department of Interior estimates that the value of up-to-date topographic maps is worth nearly $700 million annually to our national economy.